Just some introductions. I've been working for Encraft now for like 3.5 years or so, and I tend to work mostly in the domestic sort of sector quite a lot. I do quite a lot of feasibility studies, I guess, for private householders who are looking to build new houses or renovate their existing houses. So do a lot of work with houses anyway. And so this project was quite exciting for me because it was a chance to actually see a project right through from the initial feasibility right through to actually installing the kit. So yes, mostly I tend to work just on feasibilities. So this was the Retrofit for the Future competition. The purpose was to enable renovation of existing social housing stock. There were a lot of applications, 345 applications initially. Of those, 194 received contracts to actually do the feasibility study. So we actually were funded to do the feasibility study, where we came up with a plan for our retrofit project. And then half of those, or thereabouts, received contracts to actually install the work. And there was, for each project, everyone got the same sort of maximum 150,000 K, including VAT, to actually deliver the retrofit. So what was the main funders were the Technology Strategy Board. This is just a bit of a background about who they are, mainly a sort of government and part private financed sort of organisation. So this was the main challenge that we were all given. The idea was to deliver an 80% cut in carbon emissions and primary energy use against 1990 levels. So those are the targets there in terms of kilograms of carbon per unit floor area and kilowatt hours of primary energy, again, per unit floor area. So those were our targets. And this was our challenge. We had we ended up retrofitting 2 houses, part of the project. We started off hoping that we might do a few more than 2, but we had some issues with the tenants in the other 2 houses. They decided they didn't want to take part in it. So we ended up with 2 1930s semi-detached properties. They weren't adjacent, unfortunately. So we had one sort of a bit further up the street than this one shown there. They're in a rural location, so they were off the gas network and electrically heated. One had storage heaters and the other had actually a direct acting electric boiler, which the tenant nicknamed the robot, and she hated it. And the total fuel bill, that's as calculated in SAP, and it includes sort of an estimate for lighting and appliances. So it's sort of, as well as the heating and space, it's also the electricity. So for lighting and appliances. So the total fuel bill before we started work, as estimated by that methodology, is around £2,300 per year. The houses themselves had got cavity walls, but they were old cavity walls with a very narrow gap, which had been filled. But we noticed that there was the way that the bricks were, the pattern of the bricks was that we had quite regular thermal bridging going across the cavity gap as well. So quite a there wasn't much more they could do to the walls apart from externally insulating or internally dry lining. So they'd already filled them, but they still weren't very good walls, basically. They had recent double glazing installed, but they were pretty badly installed. There were lots of sort of gaps around the windows, and things weren't quite straight in a lot of the windows. So they also had solid floors with no insulation, obviously, and lofts had been topped up quite recently, so they were sort of up to the recommended depth. And actually, we started off with houses that were quite airtight. We had an air tightness test done prior to starting work, and the Q50, which is a measure of how leaky the building is, came out at 6, which is actually better than the minimum standard required for new buildings today, which is 10. So they sort of performed better in terms of air tightness than we might have expected when we first started the project. So that was our challenge. And actually, because the targets were set against 1990 levels, our challenge was a bit harder because we had worse houses than 1990 levels. We had 1930s houses, so we had to deliver more than an 80% cut in the carbon and energy in order to meet the targets that we were set. Just pointing out here as well that primary energy is not the same as the on-site energy demand. Primary energy takes into account the losses in the power station. So when you see that primary energy figure, it's not the sort of total energy consumption for the house as you would see on your fuel bills. It's actually taking account of the losses at the power station. So that's just a bit of an explanation of that there. And so just to summarise the challenge for all of the competition entries, the challenge was to deliver a whole house retrofit project that sort of dealt with all of the energy demands in the house, delivers deep cuts in carbon emissions and primary energy use. And the target on the primary energy use is really there to ensure that people don't just stick in say a biomass boiler and deliver really good carbon savings without thinking about the energy efficiency side of things. We had to demonstrate or try and think about how the work might be replicated. We had to try and include some innovation in there, and we also were required, as John's also required, to monitor the houses for 2 years after finishing all the work. So the further challenges for our project, because the uniqueness of our project was that we had 2 houses to renovate for the same money. We had a rural solution was required. We had rural location. And we also had tenants that did not want to be decanted. They didn't want to be moved out at all. That was the main thing that they said to me very early on was, we're keen to be involved, but we don't want to move anywhere. We're settled where we are, and we don't want the disruption of being moved out. So that was a real big challenge for us, as I'll go into in more depth later on. So this was our solution. This is what we came up with. The idea was to split the work down into 4 separate modules that could feasibly be sort of rolled out to like a number of houses. If you sort of did one module on a number of houses, that would be one way of replicating this sort of approach without doing sort of the whole house every time. So you could just sort of you could have a staged approach to it where you just install one of these modules maybe. So we have a non-invasive insulation module, a low carbon heating module, combined solar and lighting and appliances, and controls. So just to go into what's in all of those different modules, because the tenants didn't want to be moved out, we went for external wall insulation because that can be done while they're still in the house. There's sort of no access really indoors required for that. We decided to replace all the windows and doors, and we couldn't really think of a way of insulating the floors without moving the tenants out. So in a way we had to do better in the other areas, i.e. the walls and the windows, to make up for the fact that we weren't able to insulate the floors. So that was the non-invasive insulation. Extremely low carbon heating module. It was basically a pellet boiler, which worked quite well for us because we had existing outbuildings that we could install the boilers into. And because it was a rural location, we had a pellet supplier who's based quite nearby, and we had lots of space outside the properties for storing the fuel as well. So it worked quite well for us in that sense. The combined solar module was basically solar thermal system, domestic sized, and also a PV system. One of our houses was a east-west facing house, and the other one was a south-west facing house. So we expect to see a little bit of difference between those two systems when we get the data from the monitoring coming out. And the lighting appliances and controls was really just to fit low energy light bulbs throughout the house, install a range of A-rated white goods for the tenants. So they had a new washing machine, tumble dryers, fridge, freezers and cookers were all new. And that was the limit of our appliances module. We also installed both the V-Phase and Wokbox, which have also gone into John's property at Balsall Heath. So the Wokbox heating controller and the V-Phase actually were two of our more sort of innovative products that are new to market, and interesting to see how they perform as well once we get the monitoring data out of these houses. So our solution did not include any specific measures to improve air tightness, and that was really because of where we started off from. We were quite good on air tightness already, so when you actually evaluate the costs and benefit of improving that further, it has a long payback. And so when we were comparing that as a measure to some of the other measures we were considering, it didn't stack up for these particular houses. And that was pretty much because we were already quite airtight with these houses anyway. So similarly, we didn't specify MVHR, which is heat recovery ventilation system, and that's because we weren't going to have a home that was airtight enough for these types of systems to be efficient and to actually generate savings. So it wasn't going to work for us in this sense. We didn't specify any increased loft insulation because, as I said before, they'd been recently topped up. And so if we went beyond that depth, it was going to, again, have a long payback compared to some of the other measures we were looking at. And then, as I said before, the floor insulation was something that we decided we couldn't do because it was going to be very invasive, not really possible to do with the tenants still living in the house. And also because there's a lot of it sort of extra costs associated with insulating the floors, because you end up having to replace whole kitchens. If you're overboarding, you end up with problems with the steps, with the staircase, and the first step is like a different height to all the other steps, and apparently that's a real issue. So and if you're not overboarding, then you're going to excavate, and that's obviously going to add lots of costs. So lots of hidden costs in that. So that's why that wasn't included. And we didn't change anything to do with the secondary heating as well. I think in one house there's actually an open fire, which was left, and in the other house they've got just electric fires, which we left. And that was again because the savings were, when we analysed the savings from that measure alone, it was quite small because we used SAP to analyse all of the data for these houses. It makes an assumption about how much secondary heating contributes to the total heating demand, and that's quite small to start off with. So moving on then, just towards some of the practicalities and what happened when we actually delivered the project. The main project partners really, I guess, were Warwick District Council as property owners. They also provided some additional funding to enable us to do the two houses because we needed a little bit extra money to finish the two houses. I'll put up the costs later for the project so we can see those. And Kinetics Group were our main contractor. Kinetics are a company that already worked with Warwick District Council to manage their existing housing stock and to do things like boiler servicing and maybe install windows if that's required. So they provide like a maintenance contract for Warwick District Council's properties. So they were very keen to be involved, and they had the ability to install the vast majority of the technologies that we wanted to install. So it meant that we were able to work with a single company rather than a whole group of contractors. These are the other companies, the main set of companies that were involved. There's Wokbox providing the heating controller and also all of the data monitoring equipment. Bow Water Windows and Doors, they supplied the actual windows. Oh yeah, and they did the fitting as well. Yeah, they did the fitting as well of their own windows. Transcast did the external wall cladding. And Windhager provided the boiler, which Kinetics installed for us. So, so some of the practicalities that we experienced on site with the external wall insulation, we obviously there's a lot of work required in actually preparing the house to get it ready for the external wall insulation to go up. We needed to obviously move all of the drains, all the guttering had to be removed and new guttering was put up in the end. All of the service pipes had to be extended where they were entering into the walls. We had to extend the roof lines as well to accommodate the fact that we're putting a large layer of insulation on the gable end, and new fascias and soffits for the roofs as well. We also had, you probably can't see it very well, but there's a line of brick corbelling at the top of our houses, which was really just like a cosmetic detail on the houses when they were first built. We actually had to cut that away so that we could insulate. So we had to check that that wasn't a structural feature, and luckily it wasn't. So we were able to just cut that away and continue the insulation up. Any of the plants that were very close to the walls had to be basically moved or cut away. So that caused a bit of an issue with the tenants on one occasion. The scaffolding, and the plant thing is something that you might not think about initially when you start thinking about planning for these projects. The scaffolding as well, we had various issues with the scaffolding which went up without really enough forethought as to what would be required for the external wall insulation. I think the scaffolding was put up with the solar systems in mind and not with the cladding systems in mind. And so when the cladders came to do their work, basically we had to redo the whole scaffolding, so because it wasn't suitable for their purpose. And the main point from that is that it has to be set back from the wall slightly, and they have to have clear runs going sort of up and down the house so that they can install the boards in a safe way. So that was a real sort of issue and added extra costs to the project which could have been avoided. We were trying to minimise any issues to do with thermal bridging. We had the worst points that we had for that was we originally had concrete porch canopies over the front doors, which we ended up cutting away so that we were able to insulate continually over that wall. And we installed new actually timber frame canopies in the end. There was a bit of a discussion about what type of canopies there'd be, but they ended up being timber canopies. So that was in an effort to reduce thermal bridging, which might have happened at that point. We also had an issue where the outbuildings at the rear of the properties, which we weren't insulating because they were unheated spaces, they had flat roofs which joined on to the rear of the property at the kitchen, and so we had to sort of continue the insulation layer over the roof slightly to try and minimise the thermal bridge there. So also, what other practicalities? Yeah, we did, the picture at the bottom is the finished house on the left there, and we did a half dash effect finish on the top half, and the bottom half was brick effect. And the actual application of the dash was really, really messy work, and the tenants ended up with, their gardens were basically covered with these little dash stones. So that was a bit of potentially an issue and something to bear in mind when you're selecting finishes. I mean, dash is obviously more cost effective than the brick effect, which is very, very labour intensive. This particular brick effect finish is done by, see the top picture on the left there. Basically, they do 2 layers of render, and then they cut away the top layer to reveal a mortar colour underneath, on the layer underneath. So they basically cut the horizontal lines and then cut the vertical lines afterwards to make it look like brick. And actually it's quite effective. It looks quite a lot like brick, even from close up. So, and that's a picture of quite close up of what it looks like. So, but the main issue with that particular, going for that particular finish on the cladding was that the installers of the cladding, they had various members of the team that were able to do the boarding out and that were able to do the dash finish, but they only had a very small number of people who were actually able to do the brick effect finish. Just due to scheduling and the way the project panned out, it basically meant that they couldn't get the people with the expertise there on the right days that we wanted to have them there, and we had to wait for them to be called off other jobs so that they could come and finish the brick effect. So it was a highly skilled sort of task, and we had to wait. It caused some delay while we waited for them to be pulled off other jobs to come and finish ours. And they actually, there's some, the edging up to the neighbouring house as well, there were some areas that they forgot to do because they're sort of round the corner and maybe hidden by a plant or something, and we had to call them back several weeks later to come and actually finish off those bits of work. So so that was just one of the practicalities that we had to deal with. We installed triple glazed windows. These windows were a brand new product that Bowater have recently released. I think these were the first houses that they went in. And they were almost passive house standard windows. They've got very good overall window U value. I think it was 0.9, so it's not quite to passive house standards, but getting there. And these these windows, practicalities with the windows were, we had a bit of an issue with the lintels above the windows. So I think these houses were originally built without any lintels because they had solid wooden framed windows which don't require the structural support that PVC windows require. So there was a bit of investigative work to try and work out whether the steel reinforcements to the lintels that had gone in several years back were actually going to be sufficient to maintain the structure with these new windows that were going in. So that caused a bit of delay whilst we were trying to get the work done. We also ended up installing the windows in line with the existing walls. So the windows were brought forward a little bit because we're installing so much insulation on the outside. We wanted to bring the windows as far forward as we possibly could. And actually, I think it would have been better if we had been able to install the windows actually in the insulation layer, because that helps to really reduce the thermal bridging which comes in around the window frame when you install it. So, But we didn't do that. We just installed it sort of in line with the wall, because I think you need extra structural support if you are going to push it out into the insulation layer. And we also needed, obviously, extra large sills to overhang the depth of the insulation layer that we had, which was 120 millimetres. So, and when they actually were fitted on site, there was some concern as to whether the sills we'd actually ended up getting were going to be big enough, and they literally only just sort of come over the side of the wall. So that was a bit of an issue as well. With the wood pellet boiler, the practicalities were mostly trying to get it into the outbuildings. It took quite a long time. We ended up, I mean, it's a bit of an example of where maybe a bit more forward thinking and planning might have helped us, because the boilers arrived on site, and then there was the question of, oh, how are we going to get them around the back into the outbuildings? And of course the side access was restricted, and they ended up on the one house having to go in through the neighbour's garden, and they had to remove a fence panel in order to get the boiler in around the side of the house rather than sort of down the alleyway. And then obviously there was very little clearance in actually getting it in through the doorway and then into the space that it was required. So it took quite a long time to jiggle it into position. They are large units, these pellet boilers. They have a very large integral hopper in them, which stores a lot of fuel. In fact, actually, this might be on my next slide. Yeah, so this is about pellet storage. I mean, they have, I think, 150 kilograms you can store of pellets on the one side of the boiler, and on the other side of the boiler is the main boiler itself, which also has quite a large integral water storage, which is basically the main heat exchanger for the system, which basically needs to warm up the entire volume of water inside it before it can deliver any heat to the radiators. So that was an issue moving on, but I'll talk a bit more about that later on. But that's why they're so big. It's because they've got all this space for storing fuel and a large space for storing water. And in terms of the pellets, we estimated the annual consumption to be around 1.5 tonnes per property. And initially, I was looking into a storage solution like the one seen on the right here, which is, I think, can store 1.5 tonnes of pellets. And the idea is that it automatically feeds the boiler with an auger screw mechanism. But the tenants weren't so keen on having such a large storage unit in their garden, which is where it was going to have to go. So after explaining to them, and also actually it's better not to store 1.5 tonnes of pellets for a whole year. If you're going to use that sort of storage unit, you need to be getting through pellets quite frequently, because it's not a good idea just to store pellets for a long period of time without using them. Basically, they sort of start to degrade in terms of their properties. So after learning that, and after learning that the tenants weren't so keen to have such a large storage unit in their garden, we ended up basically having pellets delivered in bags, which we're storing in just normal sort of outside weatherproof storage containers, and the tenants have to manually feed their hopper. And we worked out that they should be filling the hopper if they, sorry?
10 times a year?
No, it's basically, it works out to be, it might be about that, yeah, but it's basically about once every 2 weeks. If they actually fill it, which they're not doing, but if they actually fill it from empty to completely full, so 150 grams, that should last them a couple of weeks in winter, assuming it's an average couple of weeks in winter. And then in summer, you know, it drops down to once every 3 months or thereabouts. It's obviously less frequent during the summer. So, and the tenants, when I explained the frequency of filling to them, they seemed happy with that. So the only issue with that is that they end up paying a bit more for their pellets because they're being delivered in bags rather than in bulk, which is what we were trying to achieve initially. So. The practicalities with the solar thermal system, I mean, both the solar systems were installed really quite easily without too much difficulty, I think, overall. But the hot water tank was quite a lot larger than their existing tanks. So, and we also needed space for the pressure vessels and the pumping station. So all of that kind of stuff took up quite a lot of room inside their airing cupboard. So they did lose a bit of space in there, which they were using for storage. So that was a bit of an issue to think about. We also replaced, there was an electric shower in one of the houses, which we thought about replacing with just a mixer tap shower, making the most of the solar hot water system, basically. So that was something to think about. Yeah, the only issue really with the PV system was the inverters, which were in short supply at the time. And we were waiting on the inverters for quite some time. And in the end, we supplied them by another route anyway. So, but that did hold up progress on site with that side of things. So that was a bit of a pain. And then just a note there about the scaffolding again, really, is that really scaffolding needs to be thought about with all of the sort of technologies in mind to make sure it's fit for purpose for all of them. So the Wokbox heating controller that has gone in, the idea with it is that it learns from the behaviour of the occupants and builds up a heating profile which matches their behaviour and the way that they use the house and when they're in and needing hot water and when they're needing some heating. So, but it was quite a simple thing to install in terms of the skills required, just the same as for a normal heating controller. So there weren't too many practical issues with it. So this is just a reminder of our challenge and the target that we had, and this is how we did. So the second column along there is where we got to with our targets. We surpassed the carbon target, and that was really because of the pellet boiler that we installed. And we didn't quite hit the primary energy target, and that was really because we weren't able to insulate the floors. So we got as close as we could without decanting the tenants, really. And if we'd tried to hit the primary energy target, I think we would have been at a stage where we would be needing to move the tenants out in order to do that work. So that's how we stacked up with that package of measures. And these are the direct benefits to the tenants in terms of savings as predicted by SAP on their energy bills. So yeah, it's about £1,800 pounds a year that they should be saving, about 81% or thereabouts. So, and actually we have already seen some of the data coming back, because the tenants have been quite closely monitoring their pellet consumption. I've asked them to fill in a little sheet every time they fill the hopper up, and actually what they've tended to do is just stick a bag in at a time. Rather than sticking 10 bags in, they'll just put 1 bag in. So they're ending up putting a bag in a day or something during winter rather than putting 10 bags in once every 2 weeks. So that's how they're doing it, and hopefully they're keeping track of how many bags they put in each time and how many pellets they are consuming. And they, one of the tenants in particular was particularly concerned about the fact that she seemed to be using more pellets than we had predicted she would use. But I think when we actually did the calculations and sat down and worked it out and compared it to a degree day analysis using degree days for that period of time, it did come in line with our predictions, and it was mostly because we had a particularly cold few weeks over winter, so she was consuming a few more pellets than we might have predicted for an average winter. But also because in her mind, she was thinking that she was going to be doing that all year in terms of the rate of filling. In her mind, she was then projecting that for the whole year, saying, well, if I carry on at this rate, it's going to cost me thousands to keep my house warm. So that just demonstrated that the level of understanding about the actual technology wasn't quite there, despite our efforts to try and explain how these things would work. It doesn't always sink in first time, basically, and there's a bit of education needed. So, but hopefully those are the savings that we're going to be delivering. These were the overall costs for the project. This basically includes everything. This is the total cost, excluding VAT. It includes all of the time that I spent managing the project, which, to be honest, most of my time was spent in liaising with tenants. And that's something that probably would have been better handled by Warwick District Council, who have tenant liaison sort of expertise, you know, within their organisation. So that particular aspect of it, potentially there are efficiencies, savings to be made there, especially if the whole sort of approach would have been a bit more proactive in terms of the liaison with the tenants from Warwick District Council's side. So it's quite interesting that. And also, obviously, it includes quite a high cost for the data monitoring systems which were installed, which were required as part of the project, but not necessarily required if you're looking to replicate this on a number of other houses. So in terms of a one-off project with all of the data monitoring, those were our overall costs. That was for both. Yes, that's for 2 houses. The question of payback is raised, and if you look at the overall costs on the previous slide and think about the overall savings on the energy bills for both houses, a simple payback analysis, it's achieving it in around 30 years. But is that really, that's not really, it's sort of irrelevant basically for social landlords who in a way, who don't experience the financial savings themselves. I mean, obviously they're concerned about fuel poverty and whatnot, but they're not so concerned about payback. So and also this simple analysis doesn't take an account of maintenance of the products and lifetimes and things. So we did a analysis where we try to think about all of those issues, which yields a cost per tonne of carbon saved over the lifetime of the measure, taking into account all of these maintenance issues, the lifetime issues, and also this is perhaps more relevant for social landlords who are targeted on their carbon savings. So, yeah, so in the end, it costs around £205 per tonne of carbon saved over the lifetime of the whole project. So that's the result of that analysis. And So I just want to spend a bit more time at the end talking about some of the lessons learnt. And the main, I guess, the main lesson learnt from it was really surrounding the tenants and having the experience of the tenants being there throughout the project. They needed a lot of time spent with them, helping them to understand everything that was going on. There were some, one of the tenants, her son had autism, and so there were some difficulties in planning for that and trying to make sure that he was comfortable with all of the work that was going to be happening and all of the contractors that were going to be on site, and it just needed a bit extra management than, say, another tenant might. She was asking for quite a detailed schedule of work so that she could go through it with him and make sure that he sort of understood all of that. The tenant in the other house, her daughter had cystic fibrosis, so there was another concern there with regards to the dust that was going to be produced during the work, and actually she ended up taking her daughter and son away for some of the time when we were doing the work, just to avoid that whole issue altogether. So there was that as a concern. I guess, yeah, also finishing touches became an issue. We ended up finishing most of the work within a 6-week period over the summer holidays, and the summer school holidays. So that was when the bulk of the work was finished, but then it took another 2 months at least to actually iron out all of the snagging points and the finishing touches really that were raised. And here's some of the sort of images that I took following the work. For example, in this one house we had storage heaters originally, and those were taken out and a wet central heating system put in. So then we had patches on the walls where obviously she had painted around her storage heaters, and then we'd taken them away and left patches on the walls. And there was she wasn't happy with our approach to that, which was basically to give her some vouchers which would enable her to redecorate the room. So there's a lot of to and froing over that, because you know, that is actually generally Warwick District Council's policy with regards to that type of thing. So they weren't willing to, they came up with some other solutions, but in the end the tenant was happy to go with the vouchers. So we talked about different options for her, but in the end she decided to go with the vouchers. So there was that, and then she also took issue with the carpet, because there was some holes where she had obviously had carpets fitted. Again, they'd cut holes for the feet for the storage heaters, and of course we've taken the storage heaters away and there's still some little holes in the carpet which are actually sort of unnoticeable, and then but she took issue with it. So it took a long time to sort of iron out all of these sort of smaller snagging points. And also the bottom two pictures show the scale of the problem that we had in dealing with, because the tenants were still in the houses. We had to shift around all of their stuff quite a lot, you know, in order to get the windows in and the radiators in. So the picture on the left there is the sort of before we've managed to sort through all their stuff, and the picture on the right is an after picture. So that was an issue that perhaps we hadn't really grasped the full scale of it before we started work. And then just, I touched on it earlier, it's just regarding the tenants and how engaged they are with the whole idea and the ideals of the project, and just their level of education with regards to the technologies. These were a couple of issues that now all the work's been finished and they're now living with the technologies that we've installed. these become more of an issue, something to think about, something to manage. And just that example with the misunderstanding with regards to the pellet consumption is an example of that. And also potentially, you know, there's some studies have shown that once you install lots of insulation and end up with a very warm house, and you know that your heating bills are going to be quite cheap compared to what you're used to, there is a tendency towards actually heating for comfort, which is a good thing because we end up with people in comfortable, happy homes, but also it doesn't reflect the savings that you might predict it to if you are literally just looking at fuel bills before and fuel bills after. There might be some behavioural factors there that we haven't thought about in too much detail beforehand. Lessons learnt with regards to the contractors. There were a number of occasions where I think a bit more planning would have helped in terms of the pellet boilers and how they got installed, and the scaffolding in particular. Also, when we extended the roof lines, they extended them and then they had to re-extend them because they hadn't extended them properly, and things like that I think there were some areas where they didn't, they fell short on the planning side. Skills was another lesson learned in relation to the brick effect rendering and how that was managed, and the fact that it was a highly skilled job and not everybody was qualified to do it. Also, there were some issues with regards to the way that the people on site managed the tenants, and it wasn't their job to be tenant liaison officers, but they ended up, we got into a few situations where the contractors were actually discussing things directly with the tenants before any decision had been made about a particular aspect, and so it ended up being so that the tenants were became very involved with some of the decisions that were made, and that was not necessarily to their benefit because they, in a way, didn't need to know about all of these little options, and I think it caused them some anxiety to actually be involved with those sorts of decisions. And I think that is a lesson learned in actually the way you manage the people who are on site if there are also tenants on site as well. So I think we could have done with maybe better site management in that respect. And then some more lessons learnt I think will be coming forward once we have the results of the data monitoring. Have we had the air tightness tests done? Oh, yeah, we haven't had the results yet from our air tightness test, which was due to be done after all the work's been done. And we also had thermal imaging done before, and they've apparently been and done it after, but we haven't received the results from that yet. So there are still more lessons to be learnt from this as we get the results of the data monitoring exercise through. So watch this space for that. And those are just, when you get the slides from those are just some links to where you can go and find out about some of the other houses that were retrofitted in this TSB funded project. And that's all I have to say really. So